Hello and welcome to Mr. Latham's AQA revision sessions. So this is the first revision session that I will be running for Physics Unit 2. As you can see on the slide, we have 7 subtopics for the P2 module. These are motion, forces, work, energy and momentum, current electricity, mains electricity, radioactivity and energy from the nucleus. So today's session we're going to be focusing on the first one, which is motion. So to start off with, we need to know what speed is. So our definition for speed is how fast an object is moving, and we calculate this using the formula speed equals distance divided by time. Now this is one of the few formulae that you will not be given on your formula sheet, so this is something that you will need to remember. So speed equals distance divided by time. Now the units for speed do vary depending on what the units for distance are and the units for time. So for example, the one that I have on the board, you can see that the units for distance is meters and the time is in seconds. And we have meters divided by seconds, so our units for speed are meters per second, and most exam questions will be giving you speed and expecting you to calculate speed in those units, meters per second. So let's just start off with an example. So Mr. Latham runs from the school gates to reception, which is 110 meters, in 19.66 seconds. What speed is he travelling at, assuming he travels at a constant speed throughout? So we get our calculator and we put in our distance, which is a 110, divided by our time period, which is 19.66. And our answer gives us 5.59511 ... So we would round that, and the rule of thumb is we round to 3 significant figures. So there's our first significant figure, our second, and here is our third. So therefore this would round to 5.60 meters per second. Now always be careful that you include the units. Sometimes in exam questions they will give you the units already. However, if they do not give you the units, then if you don't put the units at the end, even if your number is correct, you will be losing a mark. So always make sure that your answer has the relevant units. Okay, so our next stop brings us to velocity. So velocity is very similar to speed, but it is not to be confused with speed. There is a subtle difference between speed and velocity, and in its simplest definition, velocity is speed in a given direction. So, is it the same thing? Well, no, it's not. Although we quite often will use the words speed and velocity interchangeably, they are different terms. And the easiest way to think of this is using the example I've got at the bottom. So, can 2 objects have the same speed but different velocities? Well, let's think about that. So we have an object. So I'll just represent this as a rectangle. So this object having a speed. So let's imagine that this is moving in this direction at 2 meters per second. So that is its speed, 2 meters per second. And its velocity is 2 meters per second to the right. However, if I have a second box, and this box is moving again at the same speed, 2 meters per second, but instead it is moving in this direction, so in the opposite direction, then you can see they both are moving at 2 meters per second, so they have the same speed. However, they have different velocities, and you can see that they have different velocities because velocity is speed in a given direction. So the direction is very important for velocity, whereas it isn't for speed. So these 2 objects, object A and object B, although they have the same speed of 2 meters per second, they have different velocities. The top one, box A, has a velocity of 2 meters per second to the right, whereas box B has a velocity of 2 meters per second to the left. So, let's investigate the next one. So, can two objects have the same velocity but different speeds? And the answer to that is no, they cannot, because velocity, speed in a given direction, if they have the same velocity, they must also have the same speed, and also the speed having been in the same direction. Therefore, it is impossible for two objects to have the same velocity but different speeds. Okay then, so let's actually have a look at our next bit, which is about acceleration. Now, acceleration is, in its simplest term, simply an object either speeding up or slowing down. In other words, it is changing velocity. So it is the changing in velocity per second. That is the correct definition for it, and that's the definition you need to remember for your exam. So it is the rate of change of speed or velocity, and it is measured in meters per second squared, and we'll come back to that in a minute. So we have two types of acceleration. We have positive acceleration, which is when an object gets faster, and we have negative acceleration. And negative acceleration at GCSE, we can just refer to that as deceleration. So negative acceleration and deceleration are the same thing. Okie dokie then. So let's have a look at a distance time graph. So this is a readout from a tachograph which is attached to a vehicle, and we can see that we have on our x-axis time, and on our y-axis we have distance. And it is really important when you're looking at exam questions with these types of graphs that the first thing that you look at is what is on the y-axis, and in this case it is distance. And this is very, very important, and as we continue through these questions you'll start to hopefully understand why it is important that we make sure that the y-axis has been checked before you try and attempt to answer the question. So having a look at this one then, we can see to start off with, from point A to point B, we can see that as time goes by, the object's distance is increasing. And we can see it is a straight line, so therefore it is linear. And we can clearly see from that that the object is moving away from a point, but more importantly it is moving at a constant speed. So it's moving at a constant speed. Now then, from B to C we can see that as time goes by, the object doesn't seem to be changing distance. So as time goes by, the distance neither increases nor decreases. Therefore, the object must be not moving. It must be stationary. So stationary, or it's still, it is not moving. So then what about from C to D then? So from C to D you can see that the object is decreasing distance. So from A to B the distance was increasing, whereas from C to D the object is decreasing distance. Therefore the object must be moving backwards. So it's moving in the opposite direction. So it's moving backwards, but because it is a straight line we know it is moving backwards at a constant speed. And then equally from D to E you can see again it is a straight line, so it is travelling at a constant speed, and it is moving in the same direction as C to D was. Therefore we could say that this object is moving at a faster constant speed, and we know it is a faster constant speed backwards in comparison to C to D, simply because the line is a steeper line. Okay then, so sometimes on these graphs they may ask you to calculate the speed. So how do we calculate the speed of an object using these distance time graphs? And it's actually relatively straightforward, and we can work it out quite easily just by thinking of the units for speed. So on the previous slides we learnt that speed is distance divided by time. And our distance is what we have up here, and time is what we have here. So actually, when they're asking you on a distance time graph to calculate the speed, they are actually asking you to calculate the gradient of a line. And from maths, hopefully you will have learned how to do this. To calculate the gradient of a line, it is rise divided by run. So rise over run, which is difference in, or should I say change in distance divided by the change in time. And we know that distance divided by time is speed. So if I just put some values on here just to represent this, let's say the time period at the bottom is 2 seconds, and the distance here is, let's say, 6 meters. Let's just put an M there so you know it's 6 meters. So what's happened is the object has moved from here to here. It has moved 6 meters in 2 seconds. So our difference here is from our rise is 0 to 6. So it's gone up 6, and the time period for that is 2 seconds. So our rise over run, our 6 divided by 2 gives us 3. And for the units, our units for time is in seconds, and the units for distance is meters. Therefore, our units for speed are meters per second. Okay, then let's look at something slightly different then. So let's have a look at this one. So create a distance time graph for the following journey. So A to B, we have a constant speed. So it's a constant speed, so therefore we know it's going to be a straight line. And we can only assume that we start at the bottom, so we start off at 0. So we can see, to start off with, there would be a line moving upwards, just like that. And so we can see from A to B, the object is moving at a constant speed. So from B to C, it is moving at a faster constant speed. So it's still a constant speed, but it is now a faster constant speed. Therefore, again, it will be a straight line. However, this time it will be steeper than from A to B. So it would look something like that. So our next one, from C to D, we have the object has stopped. So this time the object is not moving. Therefore, we will see a horizontal line from C to D. And then finally, a tricky bit to finish off with, we have from D to E, the object is returning to the start point at an accelerating speed. So we know that it is returning to the beginning, so therefore we know that it will be going downwards back towards the bottom line. However, we know it's not going to be a straight line because the object is accelerating. So how is this going to look? Well, as we looked from the example above, you can see that the gradient tells us the speed. So if the gradient is steeper, it is a faster speed. If the gradient is shallower, then it is a slower speed. So if the object is returning to the starting point at an accelerating speed, we then can work out that the gradient must be increasing. So the gradient would very gradually become steeper and steeper, so we would end up with something that looks like that. So, and if we just have a look at this to start off with, we draw a tangent, it's very shallow, and then it becomes steeper and steeper. Okay, so that shows the object returning to the start at an accelerating speed. Okay, so acceleration. We've said that it is the change in velocity per second, and the equation for this, they do give you this equation in your exam. So it's on your formula sheet, and it is given to you in this format. So acceleration equals final velocity minus initial velocity divided by time, which really just means the change in velocity divided by time. So if we have an example, so we have a car accelerates from an initial speed of 30 meters per second to 35 meters per second in 2.5 seconds. So what is the acceleration of the car? So if we use the equation that they give you, we start off with final velocity? Well, our final velocity in the question, I'll just highlight that, is 35. So our end velocity is 35. Our initial velocity, what we started off with, is 30, divided by the time taken of 2.5 seconds. So 35 take away 30 is 5, so it is simply 5 divided by 2.5. So our answer is 2. Now the units for acceleration, it's something that I didn't mention before, but the units for acceleration is meters per second squared. So meters per second squared. And it's very important that you remember the 2, because if not, then you are representing it as speed, meters per second. So it is meters per second per second. So it's meters per second squared. And those are the units for acceleration. Okay then, so let's have a look at some velocity time graphs now. So velocity time graphs, I've drawn on there the exact same shape as we had before for the distance time graph. However, it means very different things, and that's why I said in the first slide with the graphs, it is very important that we have a look up here and check what that axis is. Is it velocity or is it distance? Because it does make a big difference. So sometimes it's represented as velocity, sometimes they will call it speed. For all intents and purposes, we will represent it as the same, velocity and speed being the same. Okay, so let's start just like we did with the last one. So from A to B, what is occurring? So start off with, we are here at 0, so we have a velocity of 0. And then as time goes by, we can see that the velocity is increasing to get to this point here. So the velocity is increasing. Now if you remember what I said before, it is acceleration, because acceleration is speeding up in its simplest term. So acceleration is an object speeding up or slowing down. So because this object is speeding up, we know that this shows the object is accelerating. More importantly, it is accelerating in a uniform pattern. In other words, it is accelerating at a constant rate. In other words, it is increasing it's increasing its speed by the same amount per second. So this could be something like an object moving from 1 meter per second to 2 to 3 to 4 to 5 to 6 every second. Therefore, it is increasing its velocity by 1 meter per second per second. So anyway, that A to B shows that the object is accelerating at a constant rate. Or we could just say it has uniform acceleration. Okay then, so from B to C, what do we see? So as time goes by, the velocity is not changing. Now let's be clear about that. The velocity of the object is not changing. It's not saying that the object is not moving. It's simply saying that the velocity isn't changing. It's neither increasing nor decreasing. However, velocity of 0 would be down here. Since our y-axis is velocity, 0 is all the way down here. And we can see quite clearly that B to C is far away from 0. So we know that the object is in fact moving. And what we would say, because the velocity is not changing, it is travelling at a constant speed or constant velocity. I'll write velocity since that's what the axis is labelled as. So it's a constant velocity. Okay then, so what about from C to D then? So from C to D you can see as time goes by that the velocity is decreasing. So what does that mean? Velocity decreasing. So it's slowing down. Now what do we call slowing down? Scientifically we would say that it has negative acceleration, or we would say that it is decelerating. More than that, we can also say that it's not just decelerating, it is decelerating at a constant rate. And we know it is decelerating at a constant rate simply because it is a straight line. So decelerating at a constant rate. Okay. And then finally, D to E, our last bit. Again, it is a straight line. Therefore, we know that it is decelerating at a constant rate, but it is steeper than C to D. So we would say that it is decelerating at a greater constant rate. but once again it is a constant rate because it is a straight line. Okay then. So, just like with a distance time graph, they may in the exam ask you to use the graph to calculate the acceleration of the object. So how would we do that? Well, we do that just like we would for a distance time graph. Since acceleration is change in velocity over time, so velocity over time, and that is change in velocity over time. That was our equation for acceleration. So velocity, change in velocity over time. Well, our change in velocity is what we have on our y-axis. It's here. And our time is what we have on our x-axis. So actually when they get you, or they ask you, should I say, to calculate the acceleration, what they're really asking you to do is to calculate the gradient of the line. So how do we do that? Just like we did for the distance time graph when we were calculating speed. So if I just put some values there, let's say that's 10 meters per second, and let's say that the time period from A to B, it's 0 to, let's say, 4 seconds. So what do? Just like we did with the distance time graph, we do rise over run. So our rise is from 0 up to 10. So our rise is 10 meters per second, and our time period is 4 seconds. So our acceleration is change in velocity 10 divided by time taken 4. Therefore our acceleration from A to B would be 2.5. Now don't forget, in the exam you need to make sure that you put the units, and because we're talking about acceleration, we're talking about meters per second squared. Meters per second per second. Okay, so 10 divided by 4 gives us 2.5 meters per second squared. Okay, before we do a different example, it is very important that we have a look at one other thing with these velocity time graphs, and that is the distance travelled. Sometimes in exams on the higher paper they might ask you to calculate the distance travelled. Now the distance travelled on a velocity time graph is calculated by looking at the area underneath the graph. So if I just do this very quickly for, let's say, the question said, what is the distance travelled of the object between point A and point C? So what we need to do is to separate this up into two shapes using a ruler. So I've just drawn two lines straight the way down, and that gives us two shapes. It gives us our triangle over here, and then it gives us our rectangle there, and then we simply need to work out the area of that compound shape. And we would do that by, let's just throw some values down here really quickly. Let's say that was 2, and let's say that was 10, and then let's say up here that is also 10. So what would our distance travelled be? So on the bottom we have 2 and 10, and to work out the area of a triangle, it's half base multiplied by height. So half of 2 is 1, and 1 multiplied by 10 is 10. So for that part from A to B it's travelled 10 meters, and then from B to C we can see it has travelled from 2 seconds to 10 seconds. Therefore the time period is 8 seconds, and the distance is the same as it was for B because it's not increased or decreased. Therefore it is 8 multiplied by 10, which is 80. Add those together will give us our total distance travelled from A to C. So therefore we have 80 plus 10 gives us 90. So our distance travelled would be 90. Now straight away, alarm bells should be going off because you've not included units. What would the units be? Well, I didn't write it over here, but let's say that our velocity is meters per second and our time period is seconds. If that is the case, then our distance would be in meters because we have meters up here, meters per second. So our distance travelled would be 90 meters per second. Okay then, so let's look at one where we have to create a velocity time graph using some statements. So to start off with, we have from A to B, there is a constant speed. Okay, so at constant speed. So constant speed means that or constant velocity, the object is not speeding up or it's not slowing down. So we would be representing that as a straight line, a horizontal line. Alright then, let's look from B to C. So B to C, we say that the object is decelerating. And I'll go a bit further, I'll say it's decelerating at a constant rate. Therefore the object will be a straight line, so the graph will show a straight line, and it will be going in a downwards pattern. And we also can see that from C to D it stopped. Therefore from B to C the object must have, or should I say the line must have gone all the way down to the bottom. And that's what we can see there. So the velocity has decreased, it's a straight line, so we know it is uniform deceleration. And then from C to D the object has stopped. So it's stopped. We know when something has stopped, it hits the bottom. That's when the velocity is 0. Therefore, in this, there would be, or it would seem to be, that there isn't anything because the velocity has stopped. So it's a straight line right on top of the x line, the x-axis line. Alright then, and finally from D to E the object is accelerating, and I will say that it is uniform acceleration. So once again we will see a straight line, but this time it will be going in an upwards fashion, just like that. So that would be a velocity time graph to represent that motion. So constant speed from A to B, decelerating from B to C, C to D it has stopped, and then from D to E it is accelerating. Okie dokie then, so that is it for the first part of motion. Thank you for listening.